Yeah. So today we'll do subnetting. So let's say, so there is a concept of subnetting. So the idea of subnetting is very clear. It's simple. It's like a dividing the big network into a bunch of smaller networks. It's very simple. If you have a big network, you divide them into a bunch of smaller networks. That's what subnetting is. So the word subnet is subnetwork. For example, subnetwork, or in a way, small network. Something like that. So that's the idea. Example, let's take it. Let's say I'm in a college or I'm in a company. My company staff, I have 100 computers, let's say. So what I can do is I can allocate one IP per computer. So I'll get 100 IPs. Let's say public IP when I said. So in a way, I can have 100 computers, just like 100 chairs. I can give one public IP per one computer. So all are connected. So that's normal. So this is not subnetting. It's just a simple. I have 100 computers, one IP per one computer, all 100 people are there. But this is not effective. The reason why it's not effective is, let's say typically a company had multiple departments. Let's say there is a tech department. Maybe there is a marketing department. Something like that. There are different departments are there. Maybe there is a HR department. Again, depends on the company. Typically, company requires maybe. Even if you think like a college, in college you have a engineering section, you have a master's section, you have PhD section. In engineering also you have computer science, you have electronics, you have, so the departments are always there. So that's why subnetting helpful. What subnetting does is it divides the entire 100 computers, example, into a bunch of smaller networks. So like you can see it in, let's say, Cisco packet tracer. So I'll do one thing. So let's say I have 100 computers like these. Assume it, I have 100. Example, assume that these are 100 computers. All are connected to one network. All are one network, we can say. All are one network. That's one network. Maybe switches are there, routers are there, everything, but it's just one network on. What subnetting does is subnetting divides them. Maybe something like this. Let's say. So maybe these three are one network. For example, maybe these three are another network. So let's say let's have a few computers. Maybe these four are another network. Let's say. Let's have switches. These three connect to one switch. These three is connected to another switch. These three is connected to another switch. Let's do basic connections. Basic only, not like actual connections, just basic. These are not actual connections, but I'll just give you illustration. Okay. Now let's add routers. I'll add one router. Sorry. So one thing. Sorry. That's one router. I add one router. Maybe I add one router. Example. Something like this. Let's say this router and this switch connected, this router, this switch connected, this router, this switch connected. Maybe there is one more router here. It connects these two. Example, I'm just making it up. Maybe there is one more router here. Connect to these two. And there is one final router. Just connected to it. Now you can see you have three different networks. You can say this entire thing is one network. This is another network. This is another network. Or you can even say that this is one network. This is another. This is another. Or you can say that this is one network. This also has another. Or you can say this entire thing is one network. You can see it, right? Initially, we saw, I think initially I deleted it. But initially you can see bunch of computers, maybe one switch, and that's one router. It's one network. Now you can see these are three different networks. Maybe we can give them label. Let's say engineering, this is a college. I can say this is a computer science department. Let's call. Maybe let's call this is electronics department. Example. Electronics department. Maybe this is last. This is, let's say, mechanical department. Something like that. We have three different departments. Let's in the college. Each department has its own network. Maybe this department, right now only three computers, but imagine that there are 100 computers. Example. You can imagine that. Please. That's it. Now, if you observe it, let's start assigning the IP address. So this is where things get interesting. Let's say the whole college has an IP address of something like this. The whole college has some IP address like 10.10.10. Let's say a star I give. Something like that. So let's say, so this is IP address. Second. Cannot increase the size. Let me see if I can increase size. Font size. Yeah, just want big font size. Let's see. Is it increasing? Okay, the font size is increasing across. Okay, that's fine. Yeah, that's fine. Okay. So now let's say the company IP address is this 10.10.10. Whatever star. Star means you can have possibilities of, let's add it here. 10.10.10. Star. In star place, you can fill anything. 10.10.10.1, 10.10.10.2, and so on, all the way to 10.10.10.255. Typically, zero also you could fill. Typically, 0 and 255 we don't really fill. Just want to tell you, 0 and 255. These are like reserve. Generally, we don't use. You can start from 1 and it from 254 typically. But you still have you can have a computer at 0, you can have a computer at 255. But these are reserve ports used for different purposes. So now we can, now let's see how many, let me ask you a question. If this is the IP address, how many devices can I connect to this entire college? How many independent devices can I assign for this entire college with this CPI? How many devices can be connected? Can you think about it? Right? Okay, so there's an answer. 3 devices. Why 3? You can have 1, 2, you can have 254. You can have 254 devices, each device one IP address. So technically you can connect 256, but 0 and 255 reserved. So you can add 254 devices connected, right? Yeah. So you can connect this to one device, this to another, this to third, all the way here. Technically, you can connect to 254 devices. So this means this college max capacity is 254. If you try another 10 computers, there is no IP for you. For that, what you do is, let's say, one member wants to join, please allow him. See, I mean, the link is public only. I don't think I can allow them, or I don't see anybody requesting me. If anybody joins, they can join automatically. There is no need for me to accept or anything. If I get anything, I'll accept it, but it's a direct join. No need, like, maybe ask him to log in with Zoom, and I think it will work. Now, let's say, what if I put something like this star? Forget about this. This is done. We can only connect 254 devices. That's done. What if the college has like this IP address? I mean, star means you can put anything. Now tell me, how many devices can we connect? Earlier, we know that like it's a star last, so you can connect all the way 1 to typically 254. That's fine. But now this is also in a way variable. Now you can change it in a way like you can say like 10 dot 10 dot, let's say 0 dot 1, 10 dot 10 dot 0 dot 2, all the way 10 dot 10 dot 0 dot 254. Okay. But at the same time, you can do 10 dot 10 dot 1 dot 1, 10 dot 10 dot 1 dot 2, all the way 10 dot 10 dot 1 dot 254. Again, you go back 1 dot 10 dot 10 dot 2 dot 1. You'll see what's happening, right? Here it's 0 first, you can connect 254. Then 1, you can connect another 254. Then 2, connect another 254, and so on. Is that it? 2. All the way down, you can connect something like this. 2251, 2251, 2254. So in a way, you can connect 256 times 256, whatever that number is. Sorry. -2. The -2 is because 0 and this you don't. That means you can have 65,000 computers you can connect. Sorry, just a second. Yeah, so you can have, if this IP, if the college has this IP structure, they can connect 65,000 computers. 65,000 exactly 534. Now, if the college IP, college has, what about this one? Then it can have more like 57, 57, 10 to 56. Let's see how big. -2. So in a way, it's 16 million, I think. Yeah, 16 million computers you can connect. So if the college has this part is variable, then they can connect 16 million devices inside the premises. If the college only have these two fixed, but these two are variable, then they can connect 65,000. If the college has fixed of these three, and this is variable, they can connect only 254 devices. Yeah, any question up to this point? So this is what they call subnet mask. Subnet mask is, it tells you which portion is network address, which portion is uh, device address, device network part, let's say network part, which portion is device part. Example, if I say 10.10.10 star, so these three are network part, we call network part. That star, last star is device part. That's one. So similarly, you can have star. So these two are network part. But these two are device part. The last is also same. Device part. Something like that. So this is what subnet mask is. Subnet mask actually tells you that which part is network address, which part is device address. They typically do it something like this. Example, you will see subnet mask like this, 255.255.255.0. This is typically you see, which means the first three octets, the first three portions are network part. The last portion is variable, which is exactly same as this side. So these three are fixed. This is changing. Typically, our computer have that on. Even on this also, if you see, if you double click, you will see subnet, which means all up to these areas are fixed. Only remaining, only part that can change is this 5, 6, 7, 8, all the way to 254. But this part is fixed. So that's the idea of subnet mask. But let's see even more detail. Subnet mask. Let's see. Look at images. Let me give you a good image. Yeah, let me give you a good image actually. Count, there is a count actually. Or I can even ask ChatGPT to generate it. Let's see. Make me a subnet table. Okay, I'll do one. I'll just copy the entire thing. Make me a table explaining all of these concepts. That's you can see subnetting is dividing large network into smaller networks. We call subnet. One company can have multiple departments, or one college can have multiple departments. A smaller segment is tech department, HR department. Why subnet is something like this. Let's see. No. Something like this. Something like this. Let's see. Let's focus on few things only. Let's focus on reverse order actually. Let's say if subnet mask is 255, 255, 255, 255. That means how many devices can be connected? Number of, see this host per subnet, usable host. So let's say this is the subnet mask, then you can have 0. That means no device you can connect. But now let's see another row, this one, follow this row. You can see this subnet mask you have, you can connect 254 devices, 256 IP address available, but 2 IP address you will not connect. So which means 254 device you can connect. That is for this. Similarly, let's go over here. You can see there is, this is subnet, 2 network part. This is device part. Max possible IPs are these many, -2. You have like these many connections. Similarly, you go this way. You can see 16 million devices connected can be possible. 16 million IPs are possible. 16 million device also possible, -2 device. And of course, if we go all the way 0, 0 means all entire pool of IP address, the entire all IP addresses, 4.3 billion roughly. So this means all IP address. Of course, nobody gives it. But let's say if I college, so those are the high level ideas. 00, this, this. You can see the CIDR number. So what this tells is how many bits are used for subnet address part. So you can say something like, let's say this one. So /8. 8 means the first 8 bits are used for network part, remaining 24 bits are device part. So similarly, if you see this, the first 16 bits used for network part, the next 16 for device part. Similarly, if we go here, the first 24 bits are used for network part. The last 8 bits are used for device part. And the last one, of course, all bits are used network only. So typically we don't use it. This is for broadcast. We do loop back. But now you can observe these numbers also. Of course, we know 32, 16, those are easy to calculate, but observe these. Observe this one now. Now your subnet mask is this. Now you tell me how many devices can we connect, or how many IP addresses are possible. So you can say that like typically this is like a binary. Binary you will get better idea. But let's see what this means is this 1111 1111 here you can have 0. 254 means not 0. I think 0 here. 401 to 412. Yeah, something like this. Exact 254 binary. I'll just quickly see. The last portion is one.